Hey everyone, welcome back to CloverX. Today I'm going to show you how I built a mini SOAR platform using N8N. And this is a complete production ready setup that you can deploy yourself. If you are wondering what the heck is a SOAR, don't worry, I'm going to explain everything. This is basically a security automation system. When security alerts comes in, like someone trying to hack into the network, this system automatically investigates it, figures out how dangerous it is, and can even block the attacker, all without human interaction. In a real security operations center, analysts would do this manually. Get an alert, look up the IP address, check if it's known to be malicious, decide how serious it is, and then maybe block it. That could take around 10 to 15 minutes per alert. This system does it in about 4 seconds. I I deployed this entire system in a VirtualBox environment using Docker. I am going to show you the conflict infrastructure setup from Ubuntu to deploying N8N in Docker to configuring the APIs to building the workflow. Before we dive into the workflow itself, let me quickly tell you that the complete setup of this N8N is uploaded on my GitHub. You can find the link in the description. Please check it out. So giving the overview about the setup, I will say that I am running Ubuntu in VirtualBox with net networking. Nothing fancy, just a basic Ubuntu installation. Then I'm running Docker. The Docker will be running the N8N on it. And I also configure the intelligence uh, two threat intelligence. Mostly, you know, if you have heard about it, it's VirusTotal and AbuseIPDB. You just need to log in on virustotal.com, log in with your account or sign up with your account, go to your profile and copy the API key. After copying the API key, you need to go to the NFN N8N dashboard. You will go to the plus sign on your left hand upper corner, click on the credentials. Here you will see the credentials. If you this is these credentials are preloaded by me, but if you are creating a new, then you have to click on the create credentials about here, create a new credentials, search for the virus total. As you can see, virus total API will appear. It will look like this. Put your API token and put the allowed HTTP request domains to all. That's recommended and pre-installed. So you don't have to change anything here. Only thing you have to add is API token. Next, second thing is AbuseDB. Do the same steps for the AbuseDB. Log into the AbuseDB account. Go to your profile. Go to your AbuseDB. Then go to your profile. Copy the API. It's my API is here. I won't be showing much. Okay. Copy the API key. And in this, you won't find the abuse abuse TV API because I don't think there is any abuse API for now. So for this, either you can do is HTTP, you can do is go to your workflow, created workflow, go to the workflow and create a HTTP request. After creating the HTTP request, you need to enable the send header to web button. In that, you have to specify headers. You have to select the field, like using field below, right? Using your JSON or using fields below. You have to select the using fields below. After choosing that, name the header with key or any name you want. Then on the value, you have to input your API key of the abuse field. After that, you can just close the the HTTP means HTTP request node. Now you will have connected AbuseDB API, yeah, or you can say the intelligence. So before before going through the uh, workflow, we will understand what is a SOAR. So starting with SOAR, the future of security operations. So okay, so first SOAR stands for security, orchestration, automation, and response. Let me break that down. Orchestration means connecting different security tools together. Your firewall, your threat intelligence, your SIEM, making them all work together. So what is orchestration? Orchestration means connecting different security tools together. Or you can say the orchestration is connecting different tools together. You can on and it can create a automation tasks. It's not basically for only security purpose. You can create it for your home, uh, for your home automation from IoTs to everything. Or you can make agent automation agent on that. Next is automation. Automation means doing repetitive tasks automatically. No human clicking buttons over and over. Response means taking action when threats are detected. Blocking IPs, isolating machine, creating tickets. So if you go for a traditional SOC, you will see this kind of steps. In normal security operations center, here's what happens. An alert comes in, an analyst has to open the alert, copy the IP addresses, check it in a VirusTotal, check it in AbuseIPDB, check threat intent feeds, decide if it's dangerous, maybe block it, document everything. If you are a SOC analyst, you might get hundreds of alerts per day. You can possibly investigate all of them manually. That's where SOAR comes in. This workflow does all of that automatically. Alert comes in, system investigates it, makes a decision, take action, done. So let me show you how I built it. Going back to the workflow. So here's the complete workflow. Let me give you the 10,000 foot view before we dive into the each pieces. So section one has webhook. This this is where alert comes in. Think of it like a doorway that security events come through. Section 2 is threat intel. Threat intelligence enrichment, we check the suspicious IP in multiple databases to see if it's known to be malicious. Then we this then there is a risk scoring. We take all that intelligence data and calculate how dangerous this actually is. Then comes the decision logic. If it's high risk, we take action. If not, we just log it. Then automated response. For high risk threat, we automatically block them or add the firewall. So the flow is alert comes in, alert come in, we investigate it, calculate a risk, decide what to do, and take action. Simple concept but powerful execution. Alright, so everything starts with this webhook now. This is our alert ingestion layer. When you activate this workflow, N8N gives you a unique URL. Any system can send security alerts to this URL and have it trigger the workflow. The most important field here is IP. That's what we are going to investigate. Is this IP address known to be malicious? In a real environment, this would integrate with your SIEM, Splunk, like SIEM, like Splunk, Wazoo, Elastic. They can all send webhook when they detect suspicious activity. You can test, we can test this by sending a post request to the URL. Here, let me show you. So we will go to our terminal. Okay. So before we execute this, we have to start the workflow. So now we will go to the workflow. Our workflow have got let's see the logs have generated here from host to user agent, blah 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 blah, and the IP. You can see the IP file login medium. Okay, so it's because the logs, I mean, the system sent the log to the webhook to our workflow. Now let's see what happens to that data. Once we have the IP address, we did investigation and using two threat intelligence providers. Obviously you have known because I told you beforehand. So that two intelligence are VirusTotal and AbuseIPDB. Let's look at VirusTotal first. You can see these expressions. It's grabbing the IP from the webhook dialog. The webhook data comes in as OD.IP, so we use OD.JSON IP to access it. Okay. Look at this A. Look at this output that the vendor flagged this IP as malicious. That's fact. This is a known threat. You can see you can say we have to focus on the reputation score. If it's negative, if it's negative, then it is paid. If I in part I seen that this is a negative 23 and it's malicious. It's hard to find it. The whole not events, not privileges, not these two, and not entities. I don't want entities. Okay. Uh, I think it's here. You will see the reputation is for 23, malicious is 14, suspicious 3, undetected 28. Okay, so it's reputation is very bad. So it's very bad for the system. And this IP has a history of malicious activity. By the way, VirusTotal is a free trial. You get like 500 requests per day, which is plenty for testing. So now let's go for the administrative. It's same concept. You will see the local host IP as everything. And here you will directly see abuse confidence score. It's 100. It's 100 and it's paid. Sorry. It's 100 and it's very paid. Oh, it's malicious IP. It's network is paid. It's not the same as direct social scoring. The virus filter gets with scores on the negative and positive, but here obviously scores on the level, on the percentage of like how malicious is, how high the score of maliciousness is of the site. Okay, now now you can see that max agent index mean index in the URL here. Okay, it's an expression and we have put that. So this means they show me reports from the last 90 days. This gives a recent abuse history, not just ancient data. Here we will access the two fields, data abuse, means we will extract the abuse confidence score and the total reports. Total reports are 176 and confidence score is 100. So now we have threat intelligence from two different sources, but they are in a different formats, different data structure. We need to normalize this data so we can work with it. That's where the merge node comes in hand. Here, merge node contains data from multiple sources into a single infrastructure. Append node means take all the data and put it together. We are not matching or joining, just combining everything into one out. So on the left we have VirusTotal, on the right, we have uh, on the HTTP we have AbuseDB, and on VirusTotal request we have VirusTotal requests. So here executing this step, we combine all the data of AbuseDB and VirusTotal. This expression for specific, I'm sorry. Notice I am not giving everything, just the important fields, and I am renaming them to be consistent. This expression pulls specific fields from the raw API response and give them clean name like witty, malicious, and abuse score. Okay, so you have it's hard to find. There is still more data we need, but you can find it if you can read the it's somewhere here. It will come in further, so don't worry. So this normalization is important because now we can easily work with this data. We have one consistent format regardless of which API we use. Now we need to decide, is this IP dangerous enough to block? This is where the code in JavaScript node comes in. So in the code, this is where we calculate the risk score. I'm using a JavaScript to implement this logic. Important important note here. Item 0 is the first input and item 1 is second. The merger node combine both API responses and now we can access them. First, we extract the key values. We'll extract the VT malicious, ambiscore, and IP. These thresholds are based on a real-world SOC experience. Five or more vendors flagging something that's definitely malicious. And abuse score about 70, that's a high confidence from the community. So here is we got the okay, IP is malicious, VT malicious 14, abuse score is 100, and this is high. We can clean object with all the important data. This makes it easy for the next node to make decisions. Perfect. High risk detected. Now we need to decide what to do about it. And to decide that, we will use the detection node. Decision node. This decision node, this is the if decision node implements conditional routing based on the risk level. We route to different paths. So if the risk field equals high, we go down the true path, otherwise false path. True path goes to the HTTP request node that simulates blocking the IP. You can see I also appended a row in Sheets. I connected in my Google Sheet. So I can, yeah, you can say this here. It will log the IP on a sheet and it can be used as a threat intel on further basis. And here is a simulation which simulates the HTTP like blocking of the IP. You can add a command prompt here, connect with your system, and directly block the IP on the system level on the firewall. Okay, so this is part. Uh, this is important for reducing false positive. We are only taking aggressive action blocking when we are very confident it's malicious. When both VirusTotal and AbuseIPDB agree this is a threat, but for high risk threat, we are making immediate action. This all is automated response when we detect a high risk IP. We send a command to block it and the firewall. Okay, so I am using the http bin.org for testing. It's a free service that echoes back whatever you send. Perfect for simulating API calls without needing a real firewall. But in production, this URL would be your actual firewall API endpoints. Okay, so the body contains all the information needed to create a firewall rule. The action, what to do, IP, which IP to block, this, why we are blocking it, and timestamp. HTTP will calls back our payload in production. A real firewall would return a rule ID or confirmation message. So as you can see, the workflow start. As you can see, end to end in action, the workflow starts. Webhook receive alert, calling virus total, calling abuse IPTB, merging data, calculating this code, If risk is high, routing to block action, sending block command to firewall and run. Just under 4 seconds from alert to block in a manual process, this would take like 15 to 10 to 15 minutes. And we have a complete audit trail. Every step is logged, what we checked, what we found, why we made it, the decision, what action we took, perfect for compliance and more post-incident analysis. So let me show you the overall architecture of what we just built. This follows a standard security automation architecture pattern. Six distinct layer, six distinct layers, each with a specific purpose. Ingestion layer receives alert from your scene. Enrichment layer gathers intelligence from multiple sources in parallel. Normalization layer makes data consistent. Scoring engine makes risk decision logic routes based on severity. Response layer takes action. And here's what makes this powerful. It's modular, each layer can be extended independently. So we built the core for platform, but this is just the beginning. Let me show you how you can extend this. You can add the code and you can use the IBM expose. You can use the thread route alien vault. Just add another HTTP request node, merge the result, and update the risk scoring logic. So, where would you actually use this in the real world? This show you understand SOAR architects, API integration, risk page automation, this incident response workflow. You can generate fake alerts, which the you can generate fake alerts, watch the system respond, understand what each component does. Perfect for learning before you touch production system. The architecture is production concept ready. We just need to add the production hardening. Use this to justify buying full SOAR platform or build your own based on this architecture. What did we just cover? We covered how SOAR platform works conceptually, alert ingestion using webhooks, parallel API calls for efficiency, data normalization and merging, risk scoring algorithm, conditional routing, and decision logic, automated response execution, security automation architecture patterns. You now understand API integration, threat intelligence correlation, risk page automation, workflow orchestration, security operations concept. This will help in your career. You can add these skills on the resume and you can showcase your skills on the LinkedIn and your GitHub profile. This is real security automation, the same concept that one like dollar enterprise solar platforms use, just implemented in a lightweight visual way. So that's how you build a mini solar platform in anything complete with infrastructure setup, threat intelligence coordination, risk scoring, and automated response. All the workflow JSON is on GitHub. Link in the description. You can import it directly into N8N and start testing immediately. Found this helpful? Hit that like button, subscribe if you want more security automation and soft content. Drop a comment. Did you deploy this? What firewall did you integrate it? Should I make part 2 showing production hardening? Remember, this is modular for design. The architecture can be extended to any firewall, any SIM, any thread suite. The concepts are universal. Thanks for watching. Stay secure out there, and I will see you in the next one.